Hey everyone, how are you? In this video, we are going to solve the lead code problem of the day, and the problem is fruit into basket. Now, the input given in the problem is an integer array, and let us call it as fruits. And the output we need to give is the maximum number of fruits you can pick. The wording of the problem is very confusing, but I will explain you the wording and what we need to do in this particular problem. First of all, you need to understand what is the input. It is an integer array, and we are calling it as fruits. But this particular integer array is actually representing a lot of trees in a row. Basically, you have lot of trees in a row which are given as an integer array. Every data in this integer array fruits at any index I, that is fruits at any index I, is actually a type of fruit on the ith tree. Basically, every data in this fruits array is a tree, right? This is a tree, and this tree is having the type of fruit. Every tree will have a different type of fruit, right? For example, if you have 5 trees, maybe 2 trees can be of mango, 3 trees can be of kiwi. But the thing is, one tree cannot have multiple fruits on it, right? So that is what the input is. The given input integer array is a tree, is a row of trees, and every data at index I is a type of fruit on the ith tree. What you have is you have two baskets. Each basket can hold only one type of fruit. You can hold unlimited number of fruits in a basket, but in one basket you cannot put multiple fruits type. You can only have one type of fruit in one basket. Let us say this is your basket, so either you can put mangoes in this particular basket, or you can put guavas, or you can put kiwis. Unlimited number of fruits you can pick and keep in the basket, but you cannot have more than one type of fruit in one basket. Now what you need to do is you need to start from any tree. That is, starting from any tree, we need to pick one fruit from every tree. That is what you need to do, and the ultimate goal is to maximize the number of fruits we can pick. Now let's try to understand this with an input. The input array fruits is 3 3 3 1 2 1 1 2 3 3 4. Now first of all, our focus will be to understanding the input. The input is actually the integer array, right, which is actually representing lots of trees. So all these are trees in a row. So I have created a row. In this I have put all these values. What I have is I have 1 2 3 4 5 6 7 8 9 10 11 11 trees in a row. These are all trees, and basically every data in this particular fruits array is representing a tree of a particular type of fruit. For example, this is 3. It means that this is a tree, it is a tree, and the fruit type of this tree is 3. This is another tree, and the fruit type is 3. It means that both of them are trees and they have the same type of fruits on this. So let us assume that type 3 fruit means that mango. Means that all the trees which has type 3 are mangoes. All are mango trees. Let us assume that this particular data 1 means that kiwi tree. That is, this tree is having fruit as kiwi. So all the trees which are having the values as 1, they all are trees which have the fruit as kiwi. So all these are kiwi fruit trees. So that is what the input is. Now what we have is we have two baskets. So let's create two baskets. Let us say this is basket number 1 and this is basket number 2. What we can do is in each of the basket we can hold only one type of fruit, that is unlimited number of fruits, but only one type. So in these baskets I can put, let us say, mangoes. So I can put all the mangoes in this, or I can decide to put all the kiwis in this, or maybe I can decide to put the fruit type 2 or fruit type 4, but I cannot keep more than one fruit type in a single basket. But I have two baskets, right? So I can select two different types of fruits and keep it in the basket. We cannot pick three types of fruit. Now we need to maximize the number of fruits we can pick, but I understand that since I have two baskets, I can only pick two types of fruits. Now the rule of picking is this one. Starting from any tree, we need to pick one fruit from every tree. For example, if I start from this tree, this particular tree can have hundreds of fruits. I just need to pick one from one tree. That's what the question says. Starting from any tree, pick one fruit from every tree. Now if I start from this particular tree, I have to pick one fruit from every tree till I can pick the fruits. What it means is, if I pick a fruit from this particular tree, I am picking a fruit type 3, right? And let's put it in the basket number 1. Now let's move to the next tree. It is of type 3. Let's again pick one fruit and put it in the basket number 1. Similarly, for this particular data or this particular tree, I can pick one fruit and I can put this in the basket number 1. Now I get to see another tree, but the type of fruit on this tree is 1. Means I can pick one fruit of type 1, but I cannot put this in the basket number 1, but I have another basket. I can put this in the second basket, right? Now the second basket is having a fruit of type 1. From every tree I can just pick one fruit, right? And once I start picking the fruit, I have to pick the fruit from every tree. I cannot skip any tree. I cannot say that since I have picked up this and this particular tree and taking the fruits and put it in the basket, since the next tree is of type 2 fruit, I cannot pick this. And the reason is, if I pick a fruit of type 2, I just have two baskets, right? I cannot put this particular fruit in any of the basket. So I cannot pick a fruit from this tree and I will have to stop. I cannot say that I want to skip this and move to the next tree. If I move to the next tree by skipping this one, I can pick a fruit from this one and put it in the basket number 2. But this is what I cannot do. I will have to start from any tree, but then after starting, I will have to pick one fruit from every tree. I cannot skip any tree. So this particular question is all about finding a continuous set of data which has just two unique values. This is what the question is. The question has a wording which might be confusing, but from all these points, we understand that we just need to pick a continuous subarray which has the longest length, which has just two unique set of data. For example, if I talk about this subarray, it has just two data. It has a 3, it has a 1. So I can select this subarray, but I cannot select this particular subarray in which I have 3 unique data. I have a 3, I have a 1, I have a 2. Reason being, from every data, I have to pick one, right? Every data is giving me a value of 1. Basically, I have to find the number of fruits we can pick, right? From every tree, we can just pick one fruit. So every tree is giving me value 1, right? So it means that if I select this particular data, it will give me one value. If I select this particular data, the total value or the total number of fruits will be 2. And since I have just two baskets, I cannot select a sub array which has 3 unique values, right? Because I will need 3 baskets. So the question is all about selecting a continuous set of data or a sub array which has just 2 unique values, and we need to select a data or a sub array which has the largest size. The length should be largest. So basically for this particular input, the actual output is this one, a sub array of 5 elements, 1, 2, 3, 4, 5. In this particular subarray, the only unique values are 1 and 2, right? So basically you are selecting two different types of fruits and they are continuous. So as a starting point, I will be choosing this particular tree from where I will start picking up the fruits, right? So the question says that we can start from any tree, but then I will have to pick one fruit from every tree. I will choose this particular point, and now let us see what's the approach to solve this particular problem. Let us say this is your data and these are the two baskets you have. We know that the output in this case is this particular sub array, right? But what is the approach? Let us try to understand the approach. See, the thing is, if you have just one input, then you can select that particular data and put it in any of the basket, and you can say that given an input of just one tree or one data, the answer will be 1. Now the moment you will see a new data, let us say the given input is having two data, we'll have to understand that this particular data is unique or same. Now since 3 and 3 is same, I don't need to select basket number 2. I can select one fruit from these two data and put it in the basket number 1. So now my answer is going to be 2. That is, I have 2 fruits. Similarly, the moment I see this one, the moment I see an array of 3 elements, all are 3, my answer will be 3. Now if I increase the size of my input, I see another data, but this data is different. Right now we just had a fruit of type 3. Now we have a fruit of type 1, but still we have another basket, we can pick it. Now let's try to increase the size. At this moment, what will happen? You will notice that this particular data is unique. It's not 3 or it's not 1, but we don't have any basket to store it. So at this point, what will be your approach? See, we know that we have got an answer of length 4 as of now, but now we are trying to increase the answer, right? Since we need to maximize the subarray size. At this point, what you need to do, if you are able to understand what you need to do at this point, you will crack the question. That's basically the intuition behind the question. That's basically the intuition behind the solution approach. That if you are able to recognize what you need to do at this point. See, the thing is, I already know that I have an answer of length 4, right? The answer is this particular subarray. The length is 4. I know that. That is fixed. I have it saved in a variable. But the moment I see a data which is third unique data in my subarray, I will have to get rid of a particular data so that my next subarray which I can create should have only 2 maximum number of unique values. So if this is my subarray, I will have to get rid of some data, right? But you cannot get rid of one. And the reason is, if you get rid of one and try to create this particular subarray, it is not valid. It is not a subarray. You cannot skip an element from between, but you can start skipping elements from left side, right? If this is your subarray, let's try to decrease the size of your subarray now. We already have an answer of 4, so we don't need to worry that our answer of this particular subarray is lost. No, we have saved it. This is my subarray. I will start decreasing the size of my subarray from the left side. So this will be my subarray. It still has 3 data, 3, 1 and 2. So I will have to keep decreasing the size of my subarray till I have just 2 unique values. So I will have to decrease this from this particular subarray to this one. And from this particular subarray, I will still need to decrease the size. I will have this particular subarray, and this particular subarray has just 2 unique data, but the size is 2, which is fine because now we can increase the size of our window or our subarray, and we can maybe get the better answer, get a subarray size of more than 4. So the thing is, guys, everything is indicating me to use the sliding window algorithm, right? Because the thing is, we are creating a window. This is a valid window. This is a valid window. This is a valid window, and even this is a valid window. But since this is an invalid window, let's try to decrease the size of our window. Now this is a valid window. Now we will again increase the size of our window till it is valid, and this is a valid window right now. It has 1 and it has 2, just 2 unique data. What is the validity of a window? It should have 2 unique data only. So if this is a valid window and now we try to increase the size, now we get to see an element which is not valid, because now we have 3 unique values. We have 1, we have 2, and we have 3. So again we have to decrease the size of our window, and we can say, alright, this can be a window. No, it still has 3 unique data. This cannot be a window, this cannot be a window, but I can have this as a window. So it is a classical sliding window problem, and we can solve this using sliding window technique. What you can basically do is, in every window, try to store a map of values. You can say, if this is a window, I have 3 which has a count of 1. In this window I have a 3 which has a count of 2. In this particular window I have a 3 of count 3. If I increase the size of the window, I have a 3 with count 3. I have a 1 with count 1. If I again increase the size of the window, I have a 2 of count 1. At this moment in my map I have 3 values. Now I will start decreasing the size of the window till my map has just 2 unique values. And at every point we just need to record our answers, and we need to store the maximum answer possible. So that is the complete approach to solve this particular problem. Now let me get back to the code editor and try to show you how can you solve this particular problem using Python. So first of all, what we have is a result variable which is equal to 0. We will store our answer in this particular variable. Then we create a data of default dictionary, basically our map, in which we are going to store the data of every subarray we will create, or basically every window. And then this is the left pointer of the window, which is 0. Then we just run a loop in our fruits array for right in range of length of fruits, and then we pick up the fruit we just got in our loop. We are going to say data of fruits of right plus equal to 1, and we need to check that the length of our data should not be more than 2. But if the length of our data is more than 2, it means our subarray has more than 2 unique values. Now we have to delete some data from our subarray. We are going to say data of fruits of left minus equal to 1. We are going to eliminate fruits from the left side, and if the data of fruits of left is 0, it means now I don't have that particular fruit in my data. I can delete that from my map. Also left will be plus equal to 1, and the moment I have a maximum of 2 unique data, I will be out of the loop, and now I can say result is equal to maximum of 2 values, the current result variable and right minus left plus 1, basically the window size. Ultimately we can return the value of result, and that is going to be the complete solution for this particular problem. You can submit this and this will pass all the test cases. You can see that the runtime is very good, the memory used is good as well. So we have solved this problem in a very efficient manner. So that's it for this video, guys. If this video helps you to understand the problem, and if this video was in-depth explanation of how to approach this problem, how to understand the intuition behind this problem, then make sure that you are hitting that like button and subscribe to the channel as well. I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.